In today's class, we are going to discuss the next topic called as boosting, heading as boosting. Okay, next heading as boosting. Now, whatever the boosting technique we are having, boosting. Boosting is also, it's also a assemble algorithm. It is also an assemble algorithm. Okay, which is combination of multiple models. What is meant by assemble algorithm is combination of multiple models. That model might be in terms of decision trees. Okay, which is generally it is a combination of multiple decision trees, which is a combination of multiple decision trees. Okay, boosting means combination of multiple models, which is nothing but combination of multiple decision trees, right? Now, this is an assemble algorithm. Now, if you consider the random forest, whatever the random forest is there, random forest is also an assemble algorithm, right? Then what is the difference between random forest versus this boosting technique? Then what is the difference? Now, random forest is called as with respect to bagging. What is the difference between bagging technique versus boosting technique? Means the major difference between these two is it is a parallel learning. It is a parallel learning. What is meant by parallel learning? Parallel learning means parallelly doing the same things. Means whatever I'm writing, simultaneously you are also going to write now. That is parallel learning. Okay. This is sequential learning. Sequential learning means first I will write. After that understanding, you'll write, right? That is called as sequential learning. When compared to this one, this will have comparatively more accuracy. Right? This is called as sequential learning. Sequential learning means one by one in the order, sequential order, not parallel. Right? So that is the difference. Now, what is meant by parallel learning means here in the parallel learning, the whatever the decision tree, it is going to form multiple decision trees, right? Here also it is going to form the multiple decision tree. Here also it is going to form the multiple decision tree. Combination of multiple decision trees. Okay, decision tree number 1, decision tree number 2, decision tree number 3. The decision tree can have multiple again furtherly divide or anything, whatever it is. Now it is a combination. Here also we are having multiple decision trees. Again, which is furtherly divided. This one also like this we are having. So in the last class, we have observed the bagging technique where it is a combination of multiple decision trees, where each decision tree is individual. There is no relation between first decision tree and second decision tree. So if you remember in the last class, that is random forest model. In the random forest model, whatever we have selected, random forest is nothing but multiple trees. Multiple trees, out of which decision tree number 1 was selected based on some random subset of data, random subset. Decision tree number 2, it was again selected on based on random subset, randomly selected. That subset was selected randomly. There is no order. Randomly it has going to choose. Now decision tree 1 and decision tree 2, what is the relation between these two? Means there is no relation. Both are independent to each other. They are not having any relation between each of them. For example, what is meant by relation means, for example, first decision tree has selected first 10 records. The second decision tree is taking the second 10 records. Then they are having the relation. They are having, each of them are having the relation. But here we are not having any kind of relation in the random forest. There is no relation. Right? So the first decision tree and second decision tree, for forming the second decision tree, it is depending on the first one means no. Whether first one is selected 10 values or 20 values or 40 values, irrespective, the second decision tree is selected. So for selecting the third decision tree, how the third decision tree is selected, it is getting dependent on decision tree 1 or 2 means no, it is selecting independently. So here, all the decision trees, whatever the decision trees are there, each and every decision tree are independent to each other. All the decision trees are independent to each other. There is no relation between each of them, independent to each other. But whereas in the boosting technique, they are having the relation. They are dependent. The second decision tree, whatever the DT2 is there, the second decision tree is dependent on the first decision tree. Is dependent on decision tree number 1. Similarly, decision tree number 3 is dependent on the decision tree number 2. So the decision tree n is dependent on the decision tree of n minus 1, the previous decision tree. It is depending on the previous decision tree. So the new decision tree is dependent on the previous decision tree. Here, all the decision trees are independent to each other. They are growing in respect of independently. Now, in this case, all the decision trees are fully grown. All the decision trees are fully grown. No pruning is done, or fully grown. Fully grown means no pruning. We are not going to do the pruning. Pruning is done only for the single decision tree. For multiple decision trees, random forest, we are not going to do any kind of pruning. No pruning is done. All the decision trees, whatever we are having, everything are grown completely from the top to end. It is going to select on the subset of the data. Whatever the data it has collected, for that complete tree, it is going to draw. Now, whereas this one, the decision trees are pruned. Whatever the decision trees are there, every decision tree is pruned. That is the difference between the bagging versus boosting technique. Now, what is the use of bagging means? It is going to reduce the overfitting problem. It will reduce the overfitting problem. Then what is the use of boosting means? It will also reduce the overfitting problem. That is one type. This is another type. Different types. One is this, both are used for reducing the overfitting problem all at the end. Right? Now, sir, can you explain the same thing in a simple example, in a simple way? So I'm going to explain with a simple example. Before explaining, please take a note. This is 90% guarantee interview question. And most of the data sets will get the best accuracy in bagging or boosting only. Most of them. Almost 95% of the data sets. For some data sets, logistic regression also gives the better answer. When we are working on the small size of data sets, that is records are less than 500 records or 400 records, something we are having, then logistic regression is sufficient. When we are working on the more data, then more data we are going to the machine means it will lead to the overfitting. When more things are given, automatically it will lead to the overfitting. That overfitting problem we are going to reduce. Done? It is clear. So let me explain with a simple example. Very simple example, easy example to understand. Okay. So you have completed data science course. Assume you have completed your data science course and now you have to take the NASCOM exam. Okay. Before going to the NASCOM exam means it is complete on the data science course, complete course. It is not only on the core Python, not only on Python for data science, it is complete course. So it includes the core Python. It includes the Python for data science. It includes with respect to the descriptive statistics, inferential statistics, the EDA, data cleaning, data wrangling, regression, and classification. Till whatever we have discussed till now, it includes all of them. All these points are included in the NASCOM exam. Now, you have to take the NASCOM exam. Let us assume you have to take after next 4 days. In next 4 days, you are going to take the NASCOM exam and you want to prepare yourself. You want to check yourself before taking the exam. Now, what you are going to do is randomly, you are going to select some random questions which are available in the Google. Randomly, you are going to select which web page you are going to select is of your choice. Some person is going to write in the Google that NASCOM questions on data science. Some person will write NASCOM questions on for Python. Some persons will write for data science or according to that, as per their choice. Now, each person will get a different websites, and based on that websites, whatever the interview questions they have collected or whatever the questions they have got, they are going to prepare. Now, randomly, they are going to choose. Randomly, they are going to select the questions which are available in Google, I mean in internet, which are available in internet. Now, we are going to select randomly some questions in the first website number 1. In the website number 1, first we'll take the questions, whatever the questions are available. First we'll try to solve them, and we have got 80%, assume. Okay, in that particular website, whatever the questions are there, within that we have solved the 80% of the questions. We have got the answers, correct answers. We have went to the second website. Is there any relation that second website should be this one only? After this website, we have to follow in this website only. Is there any relation like that? No relation. So we are going to take second website. What are the questions are there in that? And we'll see the questions and we'll keep the answers. And after that, we'll check ourselves what is the accuracy we have got. We have got 70%. Third website. We'll go to the third website, 90%. Fourth website, 85% or 80%. Fifth website, you have went, again, you have got this time 90 or 100% something. Right? You have got like this values. Now, from this, you are going to take the average value. Whatever the average is there, average value, because the percentages are continuous variable. For continuous variable, we have to apply the average. If the variable is a discrete variable, output is discrete, means we have to apply the mode. Since the output variable is continuous, we have to apply the average. So this is one way. Now, in this way, if you do like this for multiple, for example, you have not done the second website or third website. You have fixed only first website. And based on the first website only, you have got 80% and you have felt yourself, oh, I have understand the data science. I am 100% sure that I am going to qualify in the NASCOM exam. Everything is going to be perfect. I will easily get into that everything. You are overconfident or with respect to that one. Now, what happens to that at the end? For example, in the NASCOM exam, you have failed. What happened? Sir, in this website, I have got 80%, but suddenly in the NASCOM, I have failed. Anyone has told this website is NASCOM website? No, right? This is also one of the sample website. So, based on single website, if you prepare and if you feel yourself, you have understand everything means, then it is called as overfitting problem with some kind of overconfidence, right? The same thing you are doing in the next website, website number 2, website number 3, website number 4, whatever the websites we are having. If you are practicing in every website, okay, in the every website you have practiced. Now, from all the websites you have taken the average. Now, you have reduced the overfitting problem. Your confidence was not with respect to like that. Some websites you may get 70, some websites you may get 80. In some questions you may get 90. So you are going to take average. My average knowledge is this much. You are going to have that one. So instead of going on a single website and deciding, we are selecting on the multiple websites, which is called as random forest. This is the random forest example. Now, coming to the boosting example. Now, in this, if you are doing in this way, what happens? In the first website, you have got 80%. Instead of stopping there itself, you have done the multiple websites, 5 or 6 or 7 or 10 or 20 or 40 websites you have prepared. What happens? The more number of websites you do that one, more number of new questions you solve, more number of knowledge you get. And there is a high probability you may do the, you may get the high value in the NASCOM exam or in the real time in the interviews, right? Instead of going with one website, we are going to try with the multiple things. So instead of going with one website means one decision tree, we are going to take the multiple decision trees randomly. For the same syllabus, randomly we are going to choose. Data is same, but randomly we are going to choose. In that website, that question will be available. You only don't know. Randomly it was selected. Randomly we are writing the exam. Randomly we are testing ourselves. And finally we are getting the average, which is purely random, which is called as random forest model. In this case, what happened? Overfitting problem has been reduced. This is one way. Now, second way is the same. Again, you are going to take in 4 days, you are going to take the NASCOM exam. Again, you are going to prepare. Everything is same. Now, what you are going to do is, you are going to select some questions on core Python, some questions from Python for data science, some questions from descriptive statistics. And for this, what is the percentage you have got? You are going to check. You are going to take the exam all in this. You have failed in the inference statistics. You have failed in the EDA. But these all of the things are, you are very good. But these two are, you have failed. You have observed these two, you have got very low score. Now, are you going to focus on the entire syllabus? Only this particular 2 things you are going to focus. Miss, you are going to focus only on wrong things, whichever the wrongly predicted, wrongly answered, which are wrongly answered, the topics which you have answered wrongly, that you are going to focus. You are going to focus on the wrong concepts, wherever the concepts like inference statistics and area, that area you are going to focus. Now you have prepared, which you have prepared, these 2 you have prepared. Now you are going to take the attempt number 2. Attempt number 1, this is now attempt number 2. Now in the second attempt, the same questions will not be repeated. Now again, you are going to take some other sample questions. Now again, you have qualified here. Since you have prepared sincerely, obviously you will be qualified here. You have identified where is the drawback and you have prepared, right? Once you have prepared means obviously you have to solve that one. Assume that you have solved this one and this one. This time, difficult question you have got in the data cleaning and you have failed here. Again, you have solved this one and this one you have failed this time. First time you have successfully completed because the questions might be easy. You have completed. Now this time these questions are difficult and you have failed here. Again, what you are going to do? You are going to focus on this part and this part. These 2 you are going to focus. And you are going to take the attempt number 3. Now this one, already you have fixed it with respect to this one. These 2 you are already corrected yourself. You have prepared one more time also. And this one you are preparing for one more time also. Now, for example, this one is wrong this time. You have failed in the regression. Now this time you are focusing on this part. Now your attempt number 4. Now, since you have done second time, this one, and this you can't fail because you have already practiced for 2 or 3 times. Now, once everything is successful, finally, we are going to understand the things. So this is one way. Earlier example, whatever we have discussed, that random forest example is one way of reducing the overfitting. This is one way of reducing the overfitting. This way, where we are going, now we are focusing only on the wrongly answered questions. Earlier, you have focused on the multiple questions from multiple websites. That is one way of preparation. This is one way of preparation. This, whatever the attempt 1, attempt 2, attempt 3, attempt 4 are there, everything are mocks only, not the original one, mock. Why we are doing all these mocks? Because in the first original one, we have to successfully clear that one. There is no other option for us. We have to clear. One and only option we are having. We have to clear. For clearing that one, before to that only, we have to do the multiple times practice. When we are sure, 100% we are sure, then only we have to take the exam. We are not going to try our luck. We are not here to try our luck. We are here to prove our subject. So to prove our subject, we have to qualify. There is no other option for us. We have to qualify. For qualifying that one person requires mock of 1 exam. Mock test of 1 means some people will require mock of 4 tests or 5 tests. According to you, you are going to select number of mocks. 5 or 6 or 7, whatever it is. But everything are mocks only. Right? Now, this way, here also, in this case also, you are understanding each and every concept. You are identifying wherever you are having the drawback and you are rectifying your drawbacks. First step is you are identifying your drawback. Where you have failed. These 2 areas you have failed. that you are rectifying in your next step, these two should be correctly have to be done. You are identifying. Now what happens? Accuracy automatically increases. Right? So multiple times if you have done the same, wherever the wrong values are there, every time you have worked on the same, automatically finally you get the 100% pure accurate results. For getting the 100% accuracy, you have to require multiple times in between. In the first attempt only, first mock only, we may not get, because we don't know what type of questions will be there. And one way of preparation we have done, and the questions will be in a different way, might be. So we are going to take multiple mocks. Right? So this is one way of preparation. Now tell me whether that way of preparation is correct or this way of preparation is correct. The previous example, whatever we have done from multiple websites, collecting the we have seen the questions and we have solved the questions and we have tested ourselves. What is the percentage? That is correct or this is correct, miss? Both of them are correct only. That one also correct, this one also correct. Both of them at the end will help us to improve the accuracy only. But some situations that will be very good, miss. For some students, this will be good. The students are nothing but data. For some data, random forest gives the good accuracy. For some data, boosting will give the best accuracy. Okay. If you try both of them, and you combine both of them, still you get more accuracy. Right? That one and this one, if you try both of them, still you'll get more. So, after learning the boosting only, my way of preparation also has changed. When I have listened first time for the boosting technique, what is the concept of boosting is? It is identifying the wrong records. My trainer has told me that, my trainer is professor. My professor has told me, boosting technique will give the maximum accuracy when compared to other models. He has told me only this statement. I got a question. Why boosting only will give the maximum accuracy? Why other models are not able to do? Why other scientists are also scientists only. They are also has invented the algorithms. They are also invented for getting the better accuracy or better prediction. Why this one is giving that much of accuracy? What is the hidden secret inside this? If I observe, it is focusing on the wrong areas. Now, if I am focusing on the wrong areas and if I correct myself, automatically accuracy increases. The same concept, if I apply in my real life, wherever the wrong things I am doing or wherever the subject I am lagging, if I prepare one more time for the same, automatically I will increase my subject, right? The same concept I have applied in my real life. And automatically my accuracy has increased. And along with that, random forest, both the things we are applying. Right? For some things we require random forest, for some things we require the boosting. Both of them will give the good accuracies only. But the way of things are different. That is one way of preparation. This is another way of preparation. For example, one more student comes with a solution. Sir, for interviews, why can't we do the first, we can take the questions now. Sir, you share the interview questions, sir. We'll buy hat and we'll go to the next day interview room and we'll successfully clear the interview. Share us interview questions, sir. 1000 interview questions, you share us. We'll blindly buy her that one. Irrespective of whatever the answer, we'll buy her. Next day in the interview room, out of these 1000 questions, 100% within these 1000 questions only, they are going to ask at least 20 to 30 questions. Out of 30 questions, I will solve easily 27 questions or 28. I will get the job. Okay, interview is successful. Tomorrow, next day morning, you have to enter into the job, means what you will do. What is your aim? Getting an interview chance is your aim. Huh? Getting an interview chance is your aim is copy the resumes. From others, copy the resume. Copy the projects. Copy everything. You will get the interview chance. Your requirement is interview, clearing the interview means by heart the questions, interview questions. If this is your this is your aim is interview, clearing the interview only is my aim is by heart the questions, interview questions, whatever is available in the internet, easily you can crack. Getting an interview chance only means copy paste the projects, whatever the projects I have done in the class now, say that you have done the projects. Copycat, do the copycat. That is another way. This is another way. Interview, getting the interview chance is important, or interview, creating the interview is important, or getting with respect to huge salary and having a huge growth. We should not have the fear of whenever there is a recession or whenever suddenly some market people are saying that we may lose the jobs, IT jobs, miss, no problem. For me, no problem. For others might be. We should be confident on ourselves. Tomorrow might be my job will be there or will not be there. Everyday tension life. Why? Right? So what is your aim? Based on that, you have to prepare. Accordingly, you have to prepare. Right? So simple. The logic is very simple. Right? Now, coming to the Adaboost. Now getting into the Adaboost. Right? In the boosting techniques, we are having different types of boosting, out of which the boosting techniques, take the heading as boosting techniques. Out of which first one is called as Adaboost. Adaboost means full form is adaptive boosting. We'll see in the detail. Okay, second one is called as gradient boost. Third one is called as XG boost. X means extreme. X means extreme. Extreme gradient boost. Extreme gradient boost is called as XG boost. Gradient boost, a gradient boost. Two words are same. Only the word of extreme will be added. Extreme. If you understand gradient boost, extreme word is 2 minutes. It is, if you understand this concept, this is of 2 minutes concept. Just they have added the extreme word. What is the meaning of extreme? If you understand, is completed. 2 minutes. That is 2 minutes algorithm. But this is the highest algorithm, which will get 90% of the cases will get the best answer in this one only. Okay. So let us understand one by one. First, Adaboost. Let us start with Adaboost. Now, Adaboost is also called as adaptive boosting, which is an assemble of multiple models. Model 1, Model 2, Model 3. Each model is called as weak learner. In the assemble algorithm, whatever the assemble algorithm, whether it is a bagging, whether it is a boosting, in the assemble algorithm is it is a combination of multiple decision trees, multiple algorithms. So why you are taking multiple? Why you can't go with the one single one only? Why you are taking multiple? Because one is going to lead to the overfitting problem. It is a weak model. Basically, it is a weak model. Weak model is called as weak learner. So instead of going with a one weak learner, we are going to select set of weak learners and then we are going to make them into a strong. For example, one particular person is weak on doing that particular work, that particular job, he is weak. Another person or one more person, weak students are there. 3 or 4 weak students are there. If you combine all these 3 or 4 weak students, what happens? If you combine, what happens at the end? It is going to become as a strong, because this particular weak person is weak on one particular area, but he is good on some other areas, right? Similarly, he is also weak on one particular area. He is good on some other areas. Wherever he is good on some other areas, we are going to utilize that one. Whichever is weak, we are going to remove that one. So by combining the weak learners, we are going to have the strong model. So each model in the assemble algorithm, each model or each decision tree, each model is nothing but each decision tree is called as weak learners. They are called as weak learners. Weak learners means they are not sufficient to predict the answer. Individually, they are not sufficient to predict the correct answer with a good accuracy. We have to combine them. We can't predict on the single one. Single will give the wrong answers. By combining everything, we will get a better answer. Right? Now, this is a combination of multiple weak learners. So, Adaboost works by using an assemble of multiple weak learners and combining them to a weighted sum. We are going to give the weighted sum. First weak learner will have certain weightage. Second weak learner will have the certain weightage. Third weak learner will have certain weightage. And we are going to combine all of them. And finally, we are going to take. Adaboost adapts by using the previously created weak learners in order to adjust the misclassified records. Right? Now, here what is a weak learner? What is weak learner means? A weak learner itself can't give the perfect answers. It can give the perfect answers only by combining. So a weak model is a model that is too simple to perform well on its own. Now, the weak learner in particular Adaboost, the decision tree in Adaboost is called as stump. In Adaboost, this is called as stump. What is meant by stump means one root node with 2 leaf nodes is called as stump. Means where the pruning is done, pruned with a depth is equal to 1. Each decision tree was done with a depth is equal to 1. Maximum depth is equal to 1. Maximum depth is equal to 1. Earlier, I have told you the differences between bagging versus boosting, out of which the third point. What is the third point? In the bagging, all the whatever the trees are there fully grown, whereas in the boosting, the trees are pruned. Here, the pruning is done with respect to maximum depth is equal to 1. They have created the model with maximum depth is equal to 1. This is the first decision tree. And using the first decision tree, like this, we are going to combine the multiple decision trees. Now, for example, let us take this one. So there is a classification data where x1 and x2 you are having. Now, you have to take some node. Here you have to write the condition. And you have to divide the data into 2 parts. This condition, you are going to select either x1 or x2. Either x1 or x2. For example, x1 less than this value. Or x2 is less than this value. Something you are going to select. You have to draw a line, miss. You have to select either x1 or x2. Here, whatever the condition you are going to write in the decision tree, this condition is nothing but line only, right? One straight line only, right? I have told you in the decision trees, one straight line. So whatever the straight line is there. So for example, I am selecting with respect to by using the x1. I am writing like this or by using the x2. But only one line is possible. You can't take the multiple lines. Any one line, either that one or this one, right? Now, how we can combine these terms in order to get the more performance by using the assemble algorithm? How we can perform is just focus on now this. Okay, just focus. I am going to take with respect to visual representation for this data. Okay. First, what we are going to do is for this data set, first we are going to write the first decision tree. First decision tree by selecting the x1. Sir, why you selected x1? Because x1 is having the higher journey. x1 or x2, out of these 2 columns, we have to select one column. Whichever is having the higher journey, that one you have to select. I am having the higher journey with x1. Now using the x1, I am going to divide the data. Now I am going to say any value less than left side it is red data points, right side it is blue data points. Now this is red data point means correctly classified. Blue means correctly. How many misclassified records are there in this? 3 of them are misclassified. These 3 of them are misclassified. Now these 3 of them should be correctly classified in the second decision tree. The second decision tree, you have to create the model in such a way that these 3 should be correctly classified. Forget about others. These 3. Focus only on these 3. Sir, while focusing these 3, maybe misclassified, right? Okay, no problem. But these 3 should be correctly classified. Your focus is on misclassified records only. These misclassified records should be correctly classified in the step 2. So what I'm going to do, the second step, I'm going to create like this. Now in this case, above part is all the red, below part is blue. Now this is correctly classified, correctly. Whatever misclassified in the first one, it is correctly classified now. In the second decision tree, it is correctly classified, the records. Now these correctly classified records, here whatever the misclassified, this one or 2 misclassified. New records are misclassified. Now these 2 records, whichever is misclassified, these 2 records you are going to focus and you are making sure that these 2 should be correctly classified. Okay. Once these 2 records are also correctly classified, now you combine 3 of them. Just combine 3 of them. This is the first line you have drawn. This is the second line you have drawn. This is the third line you have drawn. Combine everything. Everything are correctly classified finally. First individual decision tree was wrongly classified 3 records. Second decision tree has wrongly classified 2 records. Third one has wrongly classified with certain records. But overall combining everything has correctly classified. This is the assembly algorithm, Adaboost. Example is clear? It is clear? For understanding this example, you have to understand decision tree. In the decision tree, how the condition was selected, what is meant by Jenny. And when you are writing that one, we are going to draw the line. If you remember in the decision tree, what is the first example we have taken as a retire, age versus savings. Age versus savings. We are having the scatter plot. Whether the person has to retire or not to retire. We have drawn a straight line like this, followed by a line like this. Do you remember that one? That example? First, we have drawn a straight line by using one condition. After that, we have written the one more line by using the one more condition. Right? Is that clear? Just here also the same thing. Just you are going to take the first decision tree. Decision tree number 1. Once again, I am explaining once again. Focus. Don't write simultaneously. Choice is yours. If you want to write, also write. Okay. Just observe the diagram. So we are having a scatter plot where red and green, red and blue data points are there. By using the decision tree number 1, I have drawn a straight line like this. This one is, let us assume x1 is less than 3. Out of x1 and x2 variables, 2 variables, I am having x1 is having a good Jenny, high Jenny value. Jenny index is high for the x1 variable. So based on the x1 variable, I am going to write one condition. The condition is this one. Any value, so the x1 is less than 3. Any value comes less than 3 is red. Any value greater than 3 is blue. I have taken like this. Now, when I have written like this, automatically these 3 records has been misclassified, wrongly classified. Now, in the second decision tree, my requirement is these 3 has to be correctly classified. This time, these 3 has to be correctly classified. For correctly classifying the second one, again, I am going to select with x2 and x1. 2 variables are there. Again, I am going to calculate the Jenny value. Once again, based on the Jenny value, whichever is having the higher Jenny. For example, this is having the higher Jenny means I am going to draw a line like this. For example, x2 is having the higher Jenny means I am going to draw a line like this. By this line, these 3 records are correctly classified. Everything are red, these 2 are blue. Now, these 3 records are misclassified. For example, this Jenny is high. I am going to draw a line like this. When I have drawn a line like this, automatically every value more than this is red color. Any value less than to this is blue color. Now, how many misclassified records are there? Again, 2 records, this one and this one. So my aim is now these 2 records has to be correctly classified. Perfectly, these 2 records has to be classified. For classifying these 2 records, what is the option I am having? Means this is the only option I am having. Using this option only, I can classify these 2 records correctly. So the third decision tree was made in such a way that whatever the misclassified records are there. So here the second decision tree, whatever the second decision tree is decided based on the first decision tree misclassified records. For example, I assume this record was misclassified. Now second decision tree, they will draw like this. No, right? They will draw in a different way. So the second decision tree is entirely dependent on the first decision tree misclassified record. Third decision tree was dependent on the misclassified records of the second decision tree. Since these 2 records are misclassified, our aim is these 2 should be correctly classified. Is that clear? Now, if you combine 3 of them, this is the first line, line number 1. Second line, this is the line number 2. This is the line number 3. Combine 3 of them. 3 lines you combine. This is the first line, whatever you have drawn. This is the second line. This is the third line. Combine 3 of them. Everything are correctly classified. Finally. Is that clear? Any questions? Just it is a combination of multiple decision trees. So the combination is not with respect to independent to each other, dependent to each other combination. Now let us take with the one example by taking the some data. Okay. Actual Y and predicted Y. Actual Y is yes, yes, no, yes, yes, no, yes. Total you are having 7 records are there. Now out of the 7 records, now first you are going to form the first decision tree. Decision tree number 1. Decision tree number 1 will be formed based on the whatever the values you are having, x1, x2, for example, two variables you are having. Either you are going to select x1 or you are going to select x2, and based on that, you are going to write the condition, and decision tree is formed with only stump. You have to stop here itself. You can't move up further. You have to stop here itself. After stopping here itself, now, for example, you have got the answers like this. Yes, 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 no, yes. Now, how many records has been misclassified? After decision tree 1 was built, completed, decision tree 1 is completed. Now, how many records has been misclassified? 1 record has been misclassified. Now, this particular record, we have to make sure that it should be correctly classified. The decision tree number 2 has to classify this particular record. The second decision tree output of this one should be, answer should be yes, n only. 100% it has to predict n only. In such a way, we have to create the decision tree. Right? Now, we are now how it is going to form is, first it is going to calculate the, if visual representation is clear miss, now I am going to start the mathematics behind that. If you are having any questions on visual representation, just combination, it is clear, right? How to combine, right? Yeah, I have explained once again that just you are combining the multiple weak learners in order to make the strong learner, right? Now, what is the max? How we are going to work miss? First step is we have to initialize the weight, initial weight. We have to give the initial weight. Initial weight is equal to 1 by n. 1 by n means how many records are there? Every record is having the same weight. So here 7 records are there. 1 by 7, 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 and 1 by 7. For everything, you have to give the same. Now, second step. Your second step is you have to calculate the misclassified, whatever the misclassified records are there. Misclassified records, total weight of the misclassified records. Here for misclassified records, what is the total weight? 1 by 7. This is the only one record, so 1 by 7. For example, let us assume this record and along with this record, this one also misclassified. 2 records are misclassified. Now, what is the total weight? 1 by 7 plus 1 by 7, that is 2 by 7. 2 records out of 7 records has been misclassified. That is the weight of misclassified records. If it is 1 miss 1, 2 miss 2, whatever the answer. Okay, so I am having with respect to like this, 1 record was misclassified. Only 1 record. So the sum is 1. Okay, this is represented by total error, TE. Right? After that, we have to calculate the performance of the stump. Whatever the stump, that is decision tree 1. Decision tree 1 is there. The performance of decision tree 1 is calculated by 1 by 2 log 1 minus total error divided by total error. This is the formula. Okay, we have to calculate the performance of decision tree 1. That is 1 by 2 of log 1 minus 1 by 7 divided by 1 by 7. Right? So first we have to give the weights. After assigning the weights, we have to calculate the, first we have to calculate the weighted error, weighted sum of the errors. That is sum of the weights of misclassified records. Here the weighted sum is just 1 by 7. 2 records are classified miss 2 by 7. 3 records are misclassified miss 3 by 7. 1 by 7 plus 1 by 7 plus 1 by 7. Now you have to calculate the performance. Performance is given by alpha. Alpha is equal to 1 by 2 into ln. Ln means log to base e. Ln means nothing but log to base e. 1 minus total error divided by total error. So in my case, what is the alpha value? 1 by 2 log e, that is 6 by 7 divided by 1 by 7, which is nothing but 1 by 2 log e 6. So let us open the calculator. Okay, so log ln 6, first 6 for that ln. Where is ln? ln. Okay, which is 1.79. ln of 6 is 1.79 divided by 2, which is divided by 2, which is equal to 0.895. Write that one. Whatever the answer you have got, you write. This is called as performance of the stump, whatever the first term, because these predicted values are decided based on the decision tree 1 only, right? Decision tree 1 has predicted the values. So that decision tree has predicted only one misclassified records. This is the performance. 89% it has correctly predicted, 11% it has wrongly predicted. Now, once we have calculated this performance, now we have to assign the weights. We have to assign the weights for misclassified records. The weights of misclassified records. Weights are nothing but new weight. We have to assign the new weight. New weight is equal to old weight, whatever the old weight is there, into e to the power of performance of the stump. That is nothing but wi, initial value, into e to the power of alpha. What is this one? 1 by 7 of misclassified record. For whichever the misclassified record is there, 1 by 7 into e to the power of 0.895. You have to calculate this one. Now, which is nothing but e to the power of there is power, e to the power of 0.895, which is equal to 2.44 divided by 7, which is equal to 0.3496. Right? Now, this is new weight. 0.3496 is the new weight. This is the old weight. Whatever the old weight is there, that is the old weight, and this is the new weight. New weight new. We are going to create weight new. Similarly, weight new of the correctly classified records. Wrongly classified record is this one. For correctly classified record, we have to do the new weight calculation. New weight for correctly classified records. Correctly classified records is equal to old weight into e to the power of minus alpha. Instead of plus alpha, we have to go with minus alpha. That is 1 by 7 into e to the power of 0.895 minus. And if you calculate, the value is 0.05. Okay, the value is going to be 0.05. Now substitute that 0.05 here. 0.05, 0.05, 0.05, 0.05, like this. Substitute. Okay. This is for misclassified record. This is for correctly classified record. Now, once this is done, now what we have to do is normalization of weights. Please take the note so that I will explain the normalization. First, what you have to do? You have to calculate the total error is the first step, which is nothing but 1 by 7. After that, we have to calculate the alpha, which is nothing but 1 by 2 ln of 1 minus TE divided by 1 minus TE. That is 0.895, which you have got. Right? First, you have calculated the TE value. After that, you have calculated the alpha value. After that, you have calculated the new weights, updated weights. In the coding, import Adaboost, fit on extend Vitrain. In coding, nothing will be there. In coding, only import Adaboost, Adaboost.fit on extend Vitrain. That's it. Python code is nothing. But in interview, none of them is going to ask the coding of Adaboost. They'll ask what is the math behind the Adaboost. how it is working, how the second decision tree knows this is the misclassified record. That is the most important question. All right, done. Can I erase? This is new weight for correctly classified records. This is the new weight for the misclassified records. This is the new weight for the correctly classified records. This is the new weight for misclassified records. Right? Now, once we have calculated the new weights, done guys? Or should I wait still? Wait, Done? Now, so correctly classified records, misclassified records, the new weights we have got. After new weights, what we have to do is first we have to do the total. Sum of the weights. Whatever the total weight is there, that is we have to do. That is 0.05 plus 0.05, that is 0.1, 0.15, 0.2, 0.25, 0.3, 0.3 plus 0.3496, which is equal to 0.6496. This is the sum, weighted sum. Now, what we have to do is, now the weights should be normalized. The weights normalized. Normalized means the total should be 1. Because you have started initially the total as 1. The same thing you have to continue. So, in order to get that one, 0.05 divided by 0.6496. 0.05 divided by 0.6496. 0.05 divided by 0.6496. 0.3496 divided by 0.6496. 0.05 divided by 0.496. Now, let us calculate in the calculator what is the value. The value is 0.05 divided by 0.6496, which is equal to 0.076 or 769 means 77. Let us take up to 77. Okay. Next, what about this 0.3496 divided by 0.6496, which is equal to 0.538. Okay. So this is 0.077, 0.538. This is 0.077, 0.077, 0.077, 0.077. Right? This is the after decision tree 1, this is the weights. Now after decision tree 1, now which weight is very high? Only the third record weight is very high. Now in this way, the second decision tree will understand we have to focus on the first decision tree. Now second decision tree, since the weight of this one is very high, now it will make sure that this particular record is correctly classified. The weightage you have given more high weightage, right? You have given the high priority for this one. Automatically now what happens in the next one, the decision tree is going to have with respect to this one will give the high weightage and it will be correctly predicted. This value will be correctly predicted. When this value is correctly predicted, now the total weight, Now what is the total weight? Equal to 1. Now similarly from where you have started, similarly the same thing. Now the decision tree number 2 starts. This is the decision tree number 1. Now decision tree number 2. Again it will start the prediction. Again it will calculate. Now these are the weights, initial weights. Again it will calculate the misclassified rates. For example, second time this record was correctly classified. These two are wrongly classified. Now what is the total error? The sum of the weights of misclassified records, that is these two, it is going to calculate and the process will continue. Sir, how many, still how much the process will be continued means without doing the normalization directly the new weight should be equal to 1 till that. Without doing the normalization, directly the updated weights, whatever the updated weights are there, it should be become as 1 till that the process will be continued. Or whatever the number of estimators, if you have given only 10 miss, it will stop after 10 only. It will not go with the 11th one, 11th decision tree. Though it has not got the answer also, it will stop there only. By default, the number of estimators in Adaboost is equal to 50 decision trees. It will try up to 50. Till 50 also, it will not getting the total is equal to 1. The sum of directly whatever the new weights is there, it is not getting 1 miss. Automatically, it will stop there only. Because you have stopped, you asked to stop at 50. Either 50 or in between only, if you are getting sum is equal to 1 miss, it will stop in between only. Is that clear? So that is the Adaboost calculation. So here, whatever the formulas are there, the same thing, whatever I have explained to you, the same thing here. So let us see here. Adaboost is a combination of multiple algorithms. It is not with a single algorithm. It is a sigma of f of x. F of x is first algorithm is multiple f of x. Y is equal to f of x. First algorithm y is equal to f of x. Second algorithm y is equal to f of x. And third algorithm y is equal to f of x. You have to combine 3 of them. So combination of multiple algorithms. So it is given as summation. Summation of all the multiple algorithms. Right? Now, where first initially you have to give the weights. The weights are assigned divided by 1 by n. Where 1 by n is 1 by total number of records. If you are having 8 records means each record is 1 by 8. If you are having 500 records means each record is 1 by 500. If you are having 10,000 records means each record is 1 by 10,000. Whatever that initial weight. And after calculating the initial weight, you are going to calculate the error function. For calculating this alpha t, first you have to calculate the total error. For calculating the total error is nothing but summation of misclassified weights. Summation of misclassified weights. See here, f of t is not equal to misclassified. Down the symbol, this part represents that it has been misclassified. Original data, y is original one, predicted one. Y hat I is not equal to yi. Means that particular record, whichever not classified correctly, that one you are going to do the sum. Sum of all the misclassified records, and from that misclassified records, you are going to calculate the alpha t. Once alpha t is calculated, now you are going to calculate this error function, that is e to the power of minus y into f of x, which is nothing but new weights and updated weights. Once using these updated weights, whatever the updated weights, again you are going to re-normalize such a way that the weight should be equal to 1. Now when you are moving on to the second decision tree, the sum should be 1. When you are moving on to the third decision tree, before to that the sum should be 1. When you are starting on the new decision tree, the previous decision tree, the sum of the weight should be equal to 1. Then only we can proceed on to the new decision tree. Is that clear? That is the same thing which was represented here. That is the mathematics behind that. Any questions? Too much of maths, huh? Now let me ask you the interview questions. Interview question 1. What is weak learner? That is first question. What is weak learner? Weak learner means it can't perform on its own. Okay, it is called as weak learner. Okay, it can't perform well. For example, one person is there. He can't come directly to the class individually. He wants other support only. Both of them can come to the class. Otherwise, he can't come to the class. They are weak learners. Example, right? They can't travel single. They can't come on the roads on the single. They want everyone, a company, and they will travel, right? They're weak learners, basically. Example. Similarly, here also the same. Weak learner means basically what is meant by weak learner is itself it can't perform well. Individually, it can't perform well. By combining only, it can perform well, but individually it can't perform well. That is the question, interview question number 1. Interview question number 2. In the Adaboost, they'll ask the question, what is Adaboost? Adaboost means adaptive boosting. That is full form. They are not asking the full form. What is the meaning of Adaboost? Means it is a combination of multiple weak learners where it is a combination of multiple weak learners. It is a combination of multiple weak learners where each weak learner is equal to the stump. Stump is nothing but decision tree with depth is equal to 1. Decision tree with depth of 1 is called as stump, where it is going to have one root node with 2 leaf nodes. It is called as stump, which is a combination of multiple weak learners. Whereas gradient boost, again, it is also a combination of multiple weak learners, but each weak learner is not stump there. There is different. It is entirely different again. Right? Question number 3. In the interview question number 3. Apart from what is the difference between bagging versus boosting? Question number 3 is bagging versus boosting. Okay. This is overall question. This is not related to Adaboost. Generalized question. This is generalized. What is the difference between boosting versus bagging? This is different question. Particularly in Adaboost, what is the interview questions? Miss, first question is what is weak learner? What is Adaboost? And how the performance is calculated? Performance of the stump. Performance of stump. How it is calculated? That is nothing but alpha is equal to 1 by 2 ln of 1 minus TE divided by TA. Okay. Next question, interview question number 4. Now, how the Adaboost works? By combining. Again, the same question. Adaboost works also. What is Adaboost also? Same. By combining the multiple weak learners. Just these are the interview questions. A normal person will ask in this way. Whereas SRK will ask, take a data set and explain the max behind the Adaboost. We can't do anything. For those people, we have to explain. We can't do anything. Right? In the Google, if you take with respect to interview questions on Adaboost for a data scientist, you'll get just like this, the questions. But you'll not get one question also. What is the Python code for Adaboost? You'll not get even one question also related to that. In none of the website, you'll identify that question. Python code is not important for us. Right? Some people will ask with respect to explain with math behind that. Step by step, clearly explain how the first decision tree will work. After that, how the second decision tree will take. Explain the entire max. Some people will ask. Out of 1,000, 1 person will ask like that. Very rare. Generally, theory questions. They are going to ask what is Adaboost and how the Adaboost works and what is the concept behind that. This is general questions. Is the clear? Yeah. If you are having any questions on the theory part, you can ask me. Sir, how to find the maximum and minimum capping value in outliers? That we'll discuss. Can you please ask the questions related to this Adaboost, please? High accuracy with the depth of 1. Yes, depth of 1, it is not going to give the high accuracy, right? That is the problem. That is the reason it is called as weak learner. With the depth of 1, we are not going to get the high accuracy. Obviously, the accuracy will be very low. That is the reason it is called as weak learner. It is not performing well on its own. So by combining the multiple weak learners only, we are going to create the strong learner. Strong learner was created on the multiple weak learners combination. That too, how we are going to combine with sequential order. The second decision tree is completely dependent on the first decision tree. There is a dependency between them. That is more important. This learning is called as sequential learning. Yeah, one more interview question. What is sequential learning? What is sequential learning? And what is the difference between sequential learning versus parallel learning? right? Sequential learning means where the models are dependent to each other and the second model is depending on the first one. It is in the sequential order. It is getting dependent like that means then it is called as sequential learning. Sequentially, step by step, it is learning. Whereas parallel learning means irrespective. For decision tree 1 and decision tree 2, there is no connection. Both are learning separately, on their own. Yes, it is also called as step by step learning. Nitish says that my network is not good. Please provide the recording. Nitish, to be more clear with you, I am also not having my recordings. I asked multiple times the Naresh IT team, sir, please share me the recordings, miss, sir. Anyways, you're not going to listen now. What is the use? They told like this. Okay. I also, really, there is no use for me, right? They have not even shared for me only. To share for you, first they have to share for me, right? That only the complete video access is with respect to Naresh IT team only. I'm not having the video access. Only the drive access is with me. Right? Sir, how much amount I have to pay for the recordings? Contact the admin. It is 5,000, right? Some students are saying some discount also available. Please contact the admin. You may get special discount. After so many days you are paying now, you may get. Is that clear? Anyone has any questions? Right? Now, coming to the coding part. Next one is coding part. Now, in next class, I'm going to take a data set. Okay. Now, this data set is going to consist of around 20 columns approximately 20 input variables, where all the 20 input variables are discrete only. None of them is continuous. Okay. So I'm going to select a data set in such a way where it is completely discrete data was given. None of the record is continuous variable. No one numeric value also there in the data set. So I'm going to select one data set in such a way because the reason behind this is as one of the student in the previous batches means almost 2 years back. Okay. One of the student, he has entered into the company and during that, whatever the project he is doing, and he has sent me an SMS that, sir, I'm facing the issue. I have received a data set where it is containing only the discrete data set. There is no continuous variable. Now what I have to do? He asked me that question. So I have created one project related to that, one data set I have collected related to that, and we are going to work on that. Coding part we'll see in the tomorrow's class. So in tomorrow's class, I'm going to explain the gradient boost theory part also. And furtherly, I will explain the coding part. Both of them I will compare side by side with respect to how we have done for decision tree and random forest. Similar way we can do for that one also. So that easily you can understand the difference. Right? Yeah. If you are having any questions, online, offline students, if you have any questions, you can ask. Sir, is Adaboost working on the numerical variable only or not? Yes, Adaboost works on the numerical and discrete, both. It is working on the output variable where it should be discrete because decision tree, right? Magna, sir, is there any previous batch record? None of the batch recording is with me. Not even one class recording is available. Okay. Magna, please contact the admin only. Not even one class. Sir, after if the total weight is not coming to 1, even after multiple decision trees, it will stop automatically. After 50 or so, it is not getting missed, it will stop there itself. Right? Next question is Nitish. Sir, what is the difference between Adaboost and time series? Time series data we have not discussed, right? We'll get into that. Next question is by Pawan. Sir, so here we are going to have miss after 50 models also the total sum is not equal to 1 miss. We are going to change another model. No, we are going to do the hyperparameter tuning and we are going to increase the number of decision trees, right? Number of decision trees is one of the hyperparameter in Adaboost. Done? Next one is question is, sir, when this machine learning is going to be completed? Yes, by whatever the date you have given, by that time only. Before Pongal holidays, machine learning will be completed. And you are going to take your Kaggle competition before the Pongal holidays only. Means during your Pongal holidays, you are going to take your Kaggle. Don't ask the next question, when is the Pongal holidays? I also don't know. Don't ask that question. Yeah, we have not discussed the hyperparameter tuning. I will show you the whatever the coding. When I'm explaining the coding, then I will show you the hyperparameter tuning. Right? Next, time series is also part of AI or ML. Yeah, both. In deep learning also we are going to do the time series. In machine learning also we can do the time series. Both. I will show you both also. Both are included. We'll work on that. In ML also we are having time series, and after that one also we are having the time series. Just 1 minute. Next, all the decision trees are prone to depth of 1 in Adaboost. Yes, all the decision trees. Every decision tree 1, 2, 3, 4 up to 50, everything, whatever the number of decision trees are there, each and every decision tree is pruned up to 1 only.